My dear students, now we are going to look at binary multiplier, module 4, lecture 52. Here we are going to see the simple multiplication process. It's a very simple process. Let's say I have 2-bit multiplier. So there is a multiplicand and there is a multiplier. X is a let's say X is a multiplier. Your Y is multiplicand. Your multiply X0 multiplied with Y0. So X0 multiplied with Y0 will get X0 Y0. X0 multiplied with Y0 will give you X0 Y1. It is simply like this. Say I have 1 0, then 0 1. I am multiplying. 1 multiplied by 0 is 0, 1 multiplied by 1 is 1, plus 0 multiplied by 0 is 0, 0 multiplied by 1 is 0. Then we add them. This is actually manual process. This we need to look into a process by which we are going to get from a circuit. Circuit should be capable of doing this. So this multiplication is equivalent to AND operation. So if I take an AND gate, if I give this 0 and 1, 1 and 0, when we are multiplying this with this, the output is 0, this is the 0. So the same AND gate, if I give this one and this one, this is 1, this is 1, output is 1. This is what exactly the result. Okay, next what we need to do is we need to add them. Similarly, x1 multiplied with y1, x1 multiplied with y1, x1 y0, x1 y1. Next what we do is we'll simply add them to get my final result. This is a simple process which we know. So if you add them, of course there is nothing else to add. We add them. If we may get a carry out from this additional process that may need to be carry into this stage, that you need to add it up. Then we are going to get, there may be a carry out of this addition process. So the overall result is static. So with this simple 2-bit process, if at all you want to implement in circuit, very simple. What we try to do is, we'll take y0 and y1 as an input to the AND gate and x0 as input. X0 should be multiplied with y0 and y1. So we will get, what are the terms? X0 multiplied by y0, x0 multiplied by y1. So these two terms we are going to get, this one and this one here. Next, if I take x1, it should be multiplied with the y1 and y0. Multiplication process can be implemented using AND operation. That is what exactly the thing that one has to learn here. Next, once you want to add them, if it is a 2-bit addition, I can use half adder. If it is a 3-bit addition, I can use full adder. Because there is no carry in to the from previous stage, one half adder is enough. What is half adder? Half adder is a 2-bit addition. So 2-bit addition. What is the 2-bit addition? x0 y1 and x1 y0. This is only 2-bit addition. Now if there may be a carry, I will get the sum from this half adder, but I will make it carry to the next stage. So there is a carry in. But if I look at here, I have only one operand, which is x1 y1 and carry out from the previous stage. So once again 2 bits only. Okay. So I use one more half adder and I can do this job. So 2-bit multiplication can be completed with 4 AND gates. We need 4 AND gates and 2 half adders. Okay. So we will look into the complexities as we increase the number of bits, and we try to generalize how much hardware is required and how exactly we try to deal with that. So having understood 2-bit by 2-bit, we will try to look at 3-bit by 4-bit. So this y, what is this? Is multiplicand is of 4 bits, multiplier is of 3 bits. Simple multiplication process. This needs to be multiplied with this, with this, with this, as well as this. This we need to Same process we need to complete with y1, x1 and x2. If I do that, I am going to get these product terms and this needs to be added. So what we have studied is just a 2-bit addition. If you look at here, if you want to add them, I need to add 3 bits at a time. There may be a carry coming from the previous stage, 4 bits at a time, not possible. That's why what we try to do is, we try to make a 2 bits at a time addition, 2 bits at addition, then we try to complete the overall sum once multiplication is done. So as we have learned already that what is a 2-bit adder and what is a 3-bit adder. 3-bit adder is full adder, 2-bit adder is half adder. Now what we try to do is, we will apply that knowledge, we will use AND gates and we try to complete the whole process. So if I do that, what I need to do is, for this no addition required. Okay, now we are trying to see to add the numbers. Okay, so when you want to add the numbers, this addition I need to take, I have to take care. Once I do that, I'm going to get the temporary results, because this is not the overall result. For this temporary results, whatever I'm getting after this addition process, I'm adding the next set of data, then we are going to get the final result. This we can see in a circuit diagram. So what we are doing is, we are doing x0 ANDed with y0. So this is y0 x0, this is y1 x0, this is y2 x0, this is y3 x0. Okay, so y0 x0 directly available, no need to add with anything. Okay, this we are trying to add with x1 y0 x1 y1 x1 y2 x1, then y3 x1. This is of only 2 bits, we have moved 1 bit, so we are taking the MSB bit as 0, then we are adding it. If we add it, we are going to get the temporary results. Of course, those temporary results, whatever I am getting, I am adding to the next set of data. So this may be T0, T1, T2, T3, x3 ANDed with y0, so it is y0 x3, and it is sorry, we are at x2, x2 y1, or y2 x2, y3 x2. If we add them, what we are going to get is the overall result. Okay, so in general, what I can do is, if this is of n, m and n in general, what I can say is, if I have a multiplier of m bits, multiplier, this is multiplier m bits, multiplicand n bits, let's say capital letter. So what we try to do is, we try to see in general how exactly the multiplication process will be. If there are m bits, okay, if there are m bits, here m is 3. When m is 3, how many adders we are using, how many times we are doing the addition process? 4-bit adder. 4-bit adder we are using, n is equals to 4. So we are using 2 times 4-bit adder. So the number of adders required, the size of the adder is n, or adder size. Okay, adder required is 4-bit, which is nothing but multiplicand size. And the number of addition process that we are doing is m minus 1 times. What is m minus 1? Is 2. Here m is equals to 3. What is m? Is multiplier. So 2 times I need 4-bit adder to add the the partial products what we have got it, and we are trying to get the overall final product for the multiplication process, right? How many AND gates required? I need AND gate for this, 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 AND gate for this. So because it is a multiplication, the whole number of products are m by n. So I need m by n AND gates to get the partial products. I need a adder of size n. I need adder of size n, where n is multiplicand size. I need these adders m minus m times. M minus m times I need to do the addition process to get the overall product, where m is multiplier size. So this is what exactly one has to understand the multiplication process. Okay, this is what exactly the thing. Each adder is of n bits. We need m minus n bits. We need m by n. This is what exactly we are understanding in general multiplication process. That's all. This is about n bit multipliers. With this, module 4 is completed. I will going to discuss couple of problems in the next few sessions.